Hi, my name is Kelly, and before I start my capstone presentation, I just wanted to talk a little bit about my experience at UCLA and being a part of the College Scholars Program. So I believe that my capstone culminates my experience at UCLA because it shows how I found a field and research topic that I was interested in, especially after taking different classes, exploring different research topics, and even being in a different research lab. I was able to find something that I was interested in studying and will continue to study after I graduate. And I plan to study a similar thing in grad school next year. So, and about the College Scholars Program, I wanted to talk a little bit about my experience with it. I definitely think that the program has helped me meet different people, especially in my freshman year. Going into UCLA, I didn't really know many people. So being able to go to different meetings and meeting people within the program was really nice. Um, I also got a lot of advice that has helped me through college and advice that I will also definitely use later in life. So some of this advice includes some from the first honors class that I took during my freshman year that everyone took, which was Honors 50. And I got a lot of tips about how to, how to get through college and also how to choose a career. And I also did a project that was about resilience. And so I definitely learned a lot from that class that has really stuck with me through the past 4 years. And I also got a lot of help through this program from the meetings every quarter with my honors counselor. So that's been really nice to have over the last 4 years. And I also, because of this program, got to take a lot of interesting classes that I probably never would have taken um, if I wasn't in the College Scholars Program. And so I'm really glad that I was able to take them because I learned a lot of interesting topics. Yeah. All right. And finally, I just wanted to say thank you so much for watching and enjoying my presentation. Thank you. Hi, my name is Kelly Bartlett, and I will be presenting my capstone project, which is called Improving Predictive Model Reproducibility via Machine Learning Checklists and PMML. So first, a little bit of background on machine learning models in medicine. So machine learning models in medicine are being developed with increasing frequency over the past couple of years. And here on the right is a study that was done in 2019 that showed the number of machine learning publications in PubMed from the year 2000 to 2018. And so you can see that the number of these publications has been increasing at an almost exponential rate since the year 2000. And these predictive models can be used in many different ways in medicine. So you can have healthcare data that these models can use in order to predict things such as a patient diagnosis, treatment, outcomes, and so on. But because these models are being developed so quickly, there is no standardized approach to developing these new models. So developers are using different steps, different methods to create these new models. And this leads to a problem in model reproducibility, where a model may perform well in one situation, but when it's used in a different setting or with a different data set, it doesn't perform as accurately as expected. So in order to address this problem, my lab and I are working to create a platform called Premier, which stands for Predictive Model Index and Exchange Repository. And so the goal of this platform is to have it be a tool that model developers can use in order to get feedback on their models. So what we want this platform to do is that model developers can build their models, plug it into this platform, and then get feedback on how to make their models more reproducible. And the other thing we want Premiere to do is have it be used for as a way to more easily store and transport these models and their data. So there's a couple things that we need to consider when we're building Premiere. So the first thing is, how do we evaluate machine learning models? And one method that's been used are modeling checklists. And you can think of a checklist as kind of a model roadmap. So here's an example of what a checklist may look like. And you can see from the start of the checklist, we start with defining the problem of what the model is trying to accomplish. And then we can then move into the data pre-processing, model training, down to error analysis, and things such as model interpretability, model implementation, and so on. And so the idea of these checklists is that developers can use them and go through step by step and check off that their model has each one. And then this hopefully will improve model reproducibility. However, there's a lot of these checklists that are being published, and these checklists all contain different points in them. Some include some points, some do not include them. So it's hard to tell which one to use, and there's no one comprehensive checklist. So what we need to do is have one checklist to use for predictive models in healthcare and for our platform. So the other question is, how do we compare models with each other if they're being built in different languages? So what we have to do if we want to build this platform is convert all of these models into one common language. And the language that we decided to use is called PMML, or Predictive Model Markup Language. So what is PMML? PMML is an XML-based language. An XML, which stands for Extensive Markup Language, is a language used to more easily store and transport data. And so we decided to use PMML specifically because it's used to specifically store and document machine learning model data and information. Okay, so for my part of the project, I had two main goals. The first one is to analyze and read through existing and already published machine learning checklists from across industry, research, and healthcare to create one comprehensive checklist that we could use for Premiere. So this means going through and seeing which points are included in some checklists, which points are not included, where do they agree, where do they disagree, and then based on those results, come up with one checklist that we are going to use for Premiere. Then the second step is to actually start building and testing out the platform and the Premiere pipeline. So we decided to test out the Premiere pipeline using models built in scikit-learn, which is a package in Python, and then convert those scikit-learn models into PMML. Okay, so for the analysis of the existing checklists, we found 18 recently published checklists from across research, industry, and healthcare. And we organized the information from these checklists in a heat map. So each of these columns represent one of the checklists that we analyzed, and there's 18 total here. And the rows are different items in all of the checklists. And so the red means that, the blue means that this point was addressed within that checklist. The yellow means that some of these points were included in the checklist, and the red means that it was not addressed at all in that checklist. So something that we found that was interesting about these recently published checklists is that you notice there's a lot of blue up at the top here. And so most checklists do a good job of addressing the problem definition, defining what the goal of the models are, as well as data pre-processing steps and model training and tuning. However, a lot of these checklists do not talk about performance evaluation and other things such as model comparison, interpretability, and implementation. And you can see there's a lot of red here. And so this can be a problem because which could also affect model reproducibility. So we wanted to make sure that we addressed this when we were building our checklist to use for Premier. Okay, and so this is a picture of the different steps that Premier uses in order to get an output. So I'm going to go through each step of the pipeline one by one. So the first step is to select which data sets to use. So the data that we used is from the UCI machine learning repository, and we chose 2 data sets to test out while developing Premier. And these 2 data sets are the Wisconsin breast cancer data set and the Cleveland heart disease data set. And so here on the right is kind of an example of what the Wisconsin breast cancer data set is. And it basically is a bunch of samples of cells, and you can then create a data set based on these samples. So for example, you can record the cell's area, the perimeter of the cells, the cell radius, and so on. And machine learning models can then use this information to classify whether or not these samples are benign or malignant. Okay, and so the next step is to then turn them to use those data sets and then build models with them. So the models that we created were created through scikit-learn, which is a package in Python. And we decided to use 2 different types of models just to test out our pipeline. And keep in mind that in the future, we will be testing more models. This is just to test and make sure that everything can run smoothly and that we can convert these models into PMML to begin with. So the two different models that we decided to test were decision trees and logistic regression. So next, we had to convert these models into the common language, which we decided was PMML. So we found an existing package called sklearn to PMML, which can convert your sklearn model into PMML and then store it in a PMML file. And so this package does store a lot of information about the model, but we had to use it as a starting point for Premiere because there's a lot of information that we wanted to look at with our checklist that wasn't recorded in the file. So in order to do this, we had to add that information into the file using extensions. And so PMML extensions allow us to include additional information about a model. So some examples of things that weren't included in the original PMML file from the package we found include the model name and type, the types of data used, and like we talked about with the heat map, we wanted to include model evaluation methods. Okay, so finally, we have all of the information about our model recorded in our PMML file, and now it's time to extract that information and then evaluate it against the machine learning checklist that we created in order to create a CSV output. So remove my video. So here on the right is an example of one of the CSV outputs that we got. So this one is for the heart disease, the Cleveland heart disease data set, which we then built a logistic regression model for it. And so what we did was we took the information from the PMML file and we extracted it and put it in this output, which is easier for the user to read. So here at the top, we have information about the data set and the model goal, just kind of overall some basic information about the model and data set. Next, we move into more specific information about the different attributes, such as their name and their data type and what kind of values that these attributes have. Next, we have information about the model type. So you can see here that it's a classification type of model. This is, it's also a logistic regression that came from sklearn. And finally, here we have information about evaluation methods and different performance metrics used and the scores. Oops. Okay, so in conclusion, we showed using a couple of different data sets and model types that we can take a model from the Python model that was created in sklearn and then convert it into PMML. And then this information from the PMML file can then be used and organized to evaluated against a machine learning model checklist, which can then be used to give feedback for model developers. So there's a couple of future directions. first, we need to test other data sets and types of models. This also includes models that were built in other languages besides Python. The next step that we have to do is add more PMML extensions. So if you remember from the output, the checklist that was shown was a lot shorter than the one from our heat map slide. And so that information still needs to be added, and hopefully that we can add more details about the model in the future. And finally, we want to allow user input and also to make this platform more user friendly. Right now, it's a little bit difficult to use, so hopefully in the future we can make it easier for people to use. Okay, and here are my references. Thank you so much for watching.